Okay, today we're going to look at absolute value equations as distance from a given point. In other units, in future units, we're going to look at absolute value equations or functions on a coordinate plane. But right now we're just going to use it as distance. Okay, so let's look at absolute value of x is equal to d. D is going to give us the distance, and we're going to be looking from the distance from 0. Let's look at an example. The absolute value of x is equal to 5. So we draw a number line. What we're looking for is those values that are 5 away from 0. So here's our 0. 5 to the right, we would get positive 5. 5 to the left of 0, we would get negative 5. And so our two solutions would be negative 5 and 5, as indicated in the braces, which is roster form. The other way we can do it is simply by putting a dot over negative 5 and a dot over positive 5. So two ways to represent the same solution. Roster form, which is right here, and number line form, which all of you are familiar with. Here's another way to represent absolute value. This time, since we have an x minus h in the absolute value, we are shifting our center from 0 to a value of h. Let's look at an example. H would be the center, not negative h, h itself. So what I like to think of is if I have negative h, I take the opposite of it. If I have positive h, I take the opposite of it. So negative h, our center would be h. D, again, is our distance from our center. Here's an example. X minus 3 is equal to 5. We're looking for those values that are 5 away from 3. 3 is our center. So we draw a number line, put 3 as our center. 5 in this direction would be 8, and 5 in that direction would be negative 2. So our solutions are 8, negative 2, and in roster form we'd have negative 2, 8. Okay, here's another example. The absolute value of x plus 4 is equal to 2. Remember what I said earlier, the 4 usually has a negative in front of it. So what we're going to look at here is a number line, and then we're going to have negative 4. The center is going to be the opposite of positive 4, which indicates the negative of negative 4. So negative 4 is our center. So we would have x minus minus 4, giving us negative 4 as our center. 2 away from negative 4 is negative 2. 2 to the left on negative 4 is negative 6. We fill in our two dots. Roster notation, negative 6, negative 2. When you put your answer in roster notation, the smallest number goes first, and then the numbers get larger as we go along. Let's take a quick look at roster notation. Roster notation, we use the two braces, and some people like to call them curly cues, and inside of that are numbers that are discrete. Like our answers in the first category would be negative 5, negative 1, 0, 3, and 5. No other answers at all. So when you're putting like a list of solutions, then you could use roster notation. Sometimes you can use it to do a continuous function, but the answers need to be a pattern and they still need to be discrete. So you would have ... negative 2, 0, 2, ... Those little dots are called ellipses. And I'm pretty sure you would know that the numbers after negative 2, 0, 2 are 4, 6, 8. And the numbers before negative 2 are negative 4, negative 6, negative 8. You can see that there's a pattern there. So let's recap what we learned today. First, given a absolute value equation in the first column, the second column provides our solutions in roster notation, And the third column provides our solutions in number line notation. We'll be doing more of this tomorrow in class. See you then.